So we're taking a look at continuous random variables. So remember, unlike the discrete that we were focusing on the last 2 weeks, we have the continuous variable, right? And we know that if the continuous variable is defined by the PDF f of x, then if I were to find the area under f of x between b and a, that will be the probability, total probability for that particular PDF, right? And that is equal to what? All right. If at any point in time you want to find the probability of being less than c, let's say that c is here, then the probability of less than c is the integral between c and a. So you gotta be able to integrate. As I said, it don't always come, but it don't mean that I will leave it out, right? We gotta be able to integrate. All right. So nice. So if we can integrate and you can find the probability, then we use this formula here to find e of x, the integral between b and a of multiply x by f of x between b of a, and you find e of x. To find e of x squared, you integrate between b and a again, but instead you multiply by x squared. Right? And once you have e of x and e of x squared, you can find variance. All right? So those are some of the things that we need to know. Right? Screenshot it. It's in your summary, yeah? So you already have to write down all of that. It's in your summary. Right, but just make a note. You just go and practice 1 or 2 and then come out to that, right? Let's try one now. I will try to squeeze it in right here, right? Right. Let's try a small example. Let's say I give you a continuous random variable and it has a PDF. Given PDF is just the function, right? Probability density function. And the PDF is given by kx squared, right? Between 0 and 4. So the PDF is defined between 0 and 4. All right? That's kx squared. Eh? So the first thing I want to try to find, let's see if we can find k. And next thing, let's find the probability between 1 and 3. And then let's see if we can find e of x and variance of x. Copy it down, we'll do some together. right? So nice. Let's see. All right, then red now, right? Let's see how we're doing this. So we know that the integral between 4 and 0 of kx squared dot dx is equal to 1. So we could use that rule now to help us find, k. Allowing k between 4 and 0 of x squared on 3 is equal to 1. All right. So after plug in 4 and then plug in 0 and then solve k. That's 1 over 64 and 3. So I got 3 on 64. Right? So we know what f of x is now. The f of x is 3 on 64 x squared. Anybody confused there? I just integrate and I solve for k. Any questions? So explain over, please. Oh, so all I did here, then was this, right? I said that the integral of this function between 0 and 4 is what? So I use the rule. That's the rule, right? Once you integrate between the limits, that value is what? So when I integrated it, I got x cubed on 3 by k is equal to 1. And then plug it. Remember how to integrate, add 1 to the power, divide by the new power. Right? Then I'm plugging 4, and then I make k the subsequent formula. And I got 3 on 60. That's okay? Right? Part 2 now. They want the probability between 1 and 3. So all I have to do now is integrate between 3 and 1. They integrated 3 on 64 x squared. Right? If you want, you could pull the 3 on 64 outside. Tell me where you get now. If you're in trouble and you can't remember to integrate, just plug in the calculator, right? Tell me what you get out there, please. What you got? 13 on 32, thanks. 13 on 32. All right, nice. Right? And then in a similar way, so and that's rubbing off this here, right? We all said you got 13 on 32. Right? So you all said you got 13 on 32. In a similar way now, find the integral between 4 and 0 of x by what is it again? 3 on 64 x squared dot dx. Right? That'll give you e of x, and then you have to go and find e of x squared. Right? So tell me what you got for e of x. Don't worry to integrate, right? You can just quickly calculate. Tell me what you got for e of x, what you got for e of x squared, and hence what you got for your variance. All right? Right. Oh, by the way, in the calculator, don't put x multiplied by 3 and 4x squared. Just put 3 and 64x cubed, right? Let's check it out some value, right? Let's see, I missed number of value there. Was that 3 point? The first one is 3, 9.6, and 0.6. Right? Okay, thanks. Right, so again, you can just put that straight in the calculator and work it out. You don't have to fight over the integration, right? But you must have a good Casio, right? You must have a good Casio to do that. You don't have to fight over any integration. There's no maps. There's just being able to pull those values off, right? Any questions there? All right, nice. So, just one more example I want to look at. Sometimes it will be that simple, right? Sometimes they want to give you a little bit more for you to catch and work out, right? I'm just doing one like this. I haven't seen them in the recent years, right? I'm just doing one like this for you, right? Right. So sometimes they might give you a continuous random variable. Same continuous random variable, but look at the PDF. It's called a piecewise function. So this function a little bit harder because they split it up into 4 parts. X by k by x plus 2 squared. That's not looking for a shorter one, eh? That's not, give me 1 second, okay? Right, what's this one? K between 0 and 2, 2 not included, right? Then a next function, 2x minus 3 from 2 until 3 and then 0 otherwise. So what I gave you there is a continuous random variable, right? Of course, they want you to find k. They want you to sketch it. And then let's just find one thing, right? Let's find the probability of x is less than or equal to 1. Nice. How are we doing something like this? Well, in questions like this, it's broken up, right? It's broken up. If you look at the function here, it's broken up between 0 and 3. Between 0 and 2 is one thing, right? Between 2 and 3 is something else. But it's the same function. It's something like this. So between 0 and 2 is one thing, and then between 0 and 3 is something else. Right? But it's one function. It just has two, it just split into 2. Between 0 and 2, and then between 0 and 3. Sorry, between 2 and 3. So I'm gonna do part 2 first just to give you a little idea. This sketch, and then we will find k, right? So your graph might look something like this. 0, 1, 2, 3. Right? Between 0 and 2 is k. And then if you look at this, 2kx minus 3k, can multiply it out. That's a straight line. Gradient is 2k, y-intercept minus 3. So it might look something like that. Might be a gradient looking like that, right? I could be wrong, k could be negative. But it don't matter. We can still figure out everything that we need. Now, how do I find k? Well, in order for me to find k, in order for me to find k, I could find the area here and the area here. And when I add up both areas, I will end up with 1. Or if I integrate, but it's straight line. So this one you don't really have to integrate. Right? But anyway, if I find area 1 and area 2, I am going to get 1. All right? And then I can use that now to find k. And once I have k, I can easily find anything they want me to find. All right? So try that now. I'm giving you 2 minutes. Not much of it try, but I did Jesse there try it. I know who else tried. Jaden trying a little thing. All right, take a 2 minutes and try that. Is it looking for a little hint? Might be looking for a little hint, remember? Here easy, right? A1 easy, A1's a rectangle. So I got 2. So I got 2 multiplied by 3. A2 on the other hand, a little bit harder. This is half the sum of the 2 parallel sides. Need to find here. So if I plug in 3 into this equation, 2 by 3 is 6, minus 3 is 3. I got 3k. Right? So what will that be? Half the sum of the parallel sides, k plus 3k multiplied by 1. 1 is the width, right? And you make that equal to 1. So I have 2k plus 4k, half of that is 2k. I got k to be 1/4. Anybody got that? K to be 1/4. Everybody get k to be 1/4? Yeah. 1/5. Check it out one more time. Remember, the width is 1, eh? The width is 1. 3/2 is 6 minus 3. That's 3k. Yeah, again, parallel sides should be k and 3k. That's 4k. And the width of that is 1. If you're not getting that's gonna pick how you're working. I'm gonna check it. Anybody else get quarter? Check it out. Oh, okay, okay. All right, nice. All right, nice. Let us. So I'll just show you one like that if ever that comes again, right? Any questions there? Those who actually paying attention. Jaden, you okay with that? You still have one more part, yeah? You still have one more part. Hey, Tyler. You still have one more part. You need in the one more part, you need to find the probability less than 1. Try that first. That's right here, right? Find the probability less than or equal to 1. Let me see if Darian might send anything now. Maybe not there, but let me just see. We have to believe. Mr. Darian will send something. Say something and ding 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 ding. Any answers? Hurry up now. Right, we know what K is, right? Anyway, I know it's enough. So we know what K is. K is equal to a quarter. So I just have to find the area of this rectangle here. So that's 1 by a quarter. So the answer is 1/4. Alright? Alright, nice. I just wanted to do one like that. I'm not doing many of those, right? Right, we know how to find the expected and the variance and so on. Right, before we jump back into just going over the normal distribution, right? Because you recognize any questions, you need to know your normal distribution, right? Alright, we need to know the normal distribution. We have to learn about something called the cumulative. We have to learn about something called the cumulative distribution function. Right? This function is like, just like when you did cumulative frequency, where you accumulate all the frequencies, it's very, very similar. So I'm just giving you a raw example, right? Let's say I gave you a distribution like this. And I know it's discrete, but let's say I gave you something like this. 0, 1, 2, 3. Here is, let's just say that is a uniform distribution. Right? When they say cumulative now, what they're gonna do, if I say the cumulative or the probability of one cumulative, it means add up 1/4 and 1/4. Right? It could be cumulative less than 2 is all of these probabilities here. So if you're cumulative, you're going to be adding up all the probabilities. So because of that, this comes into play. You're going to see something called f of t. Once you see capital F indicates the cumulative distribution function. If you see lowercase f, like f of x, that is your normal distributive probability distributive function, right? So what does f of t represent? F of t represents the probability of x is less than or equal to t. How are you getting that? You're integrating between t and whatever the lowest value is. Right? Whatever the lowest value is, let's assume for now generally is negative infinity. Right? So that's the way you find f of t. If I had to do it on a little graph for you, this is your f wherever f of x would have been. Let's say this value is a. Let's say this value is b. Then f of t would be this here. Right? F of t would be that shaded region. Okay? Notice I have to keep using uppercase F. I have to keep using uppercase F in order for me to identify that I'm using cumulative distribution function. Right? In this example here, if I found f of b, well, f of b is the integral between b and e. That's on this example, right? Of f of x. So in this case, only in this case, f of b is equal to 1. In this case, right? But if b is always the last value, then a is always going to be equal to 1. So f of b is 1. All right. This question comes ever so often, sometimes, oh, sorry, in case of writing. This question comes ever so often. F of m is equal to 0.5, right? That's if you want to find your median. If you want to find a lower quartile, f of m is equal to 0.25. If you want to find your upper quartile, similar thing, right? 0.75. If you want to get Q1, f of Q1 is 0.25. F of Q3 is 0.75. So you could use your cumulative distribution function to obtain quartiles. Y'all did this in school? You should have done this one. Copy it down. Can I change? Let's try one, right? Okay. All right. Yeah, well, yeah, we don't spend too much time, but it's something I want to understand, right? It's something that I really want to understand because the next part of this is the unit one, the normal distribution, right? We already did the approximations where it converted the Poisson and thing to the normal. So we kind of went through that already. So it's just this technically and module two done. It's the last thing in, oh, sorry. Chi-squared. I'll just show you about chi-squared. Unit one was independence. This one is goodness of it. A little bit long though. All right. Let's try one now. So I've given you the variable. Oh, by the way, if you have, just make a note of this. If you have the PDF, to go to the CDF, this is capital F and lowercase f of x. This is uppercase, right? To go here, we differentiate. Sorry. To go here, we integrate. To go here, we differentiate. So if they give you a CDF and they ask you to find the PDF, you have to be able to differentiate. Right? That's a little bad thing there because you have to know how to integrate and differentiate for this one. Right? This one a little bit different. This one you can't just plug it in the calculator. All right? So let's try an example. Let's say x is a continuous random variable. F of x is equal to 1/8x between 0 and 4. Right? So we know what the function will look like, right? 1/8x might look something like this between 0 and 4. Right. First time we're gonna try one of this, right? Let's see if we could find the cumulative density function and then sketch it. Okay. So how do we get the cumulative density function? Well, I'm gonna show you it here. I'm changing color, right? I just want to highlight it. So for me to find f of t, I have to integrate. So I need a function. So t is something that always going to change, right? So t will be my upper limit, right? So like if they want me to find f of 1 or f of 2 or f of 3 or f of 4, t will vary. And the lower limit is 0. And I'm going to integrate the PDF they gave me. The PDF they gave me is 1/8x. So when I integrate that now, I'm going to get x squared on 16, I think. And when I plug in t, I'll get t squared on 16. So now I sort of technically I have an equation here, right? I have an equation that I can use to help define the cumulative density function, right? So it is, you're not going to write t squared, right? T squared just to tell you what the equation is. So the equation is x squared on 16, right? For all the values between 0 and 4. For all the values between 0 and 4. But that's not good enough, huh? It's not good enough just to write that. You have to tell them what happens when x is less than or equal to 0. Of course, we know nothing happens down there on that graph, right? Nothing happens down there. But what happens when x is more than or equal to 4? Well, remember it's cumulative, right? So by the time you accumulate 1 and 2 and 3 and 4, you would have reached a probability of 1. So even if you go on to 5 and 6 and 7, it don't matter. Your cumulative function will always be 1. So your graph now will look something like this. That's a quadratic, right? X squared on 16 is a quadratic up until 4, and anything more than 4 is 1. So your graph will look something like that. So that's where your CDF is, right? And to show you how I use, if I want you to find the probability of x is less than or equal to 1, I could simply find f of 1. So that's 1 squared on 16, which is 160. Right? And that's it. That's all you really need to know about CDF. Sorry, that's all you need to know how to sketch your CDF. Any questions? If I ask you to find median, well, just find f of m is 0.5. If I ask Q2, Q3, I mean, 0.75 on sulfur. Right, on the other side of the coin now, if I give you the CDF and ask you to find the PDF, you have to differentiate this. The differential of x squared on 12, for those who don't remember, minus 1 from the power, sorry, bring down the power, minus 1 from the power. So you'll get x over 8, between 0 and 4. That's what we had earlier. All right? So it's important that you can move in between, right? Move from one to the next. Okay? It's important that you can move from one to the next and just really find it. Any questions, Olia? All right. I think there's one of the years that we were doing, we will go back and do it, right? Right? But anyway, that kind of brings us to the end of module 2, because now we know about the normal distribution and we know how to find the table values and things, right? So we can jump that paper now. Oh, my iPad going dead. My iPad going on dead. All right, that's a slight problem there earlier. Should we get up one day? Quick. I don't know how much charger. On them bed. Everybody come on the if I do this, huh? We had to this one? Yeah, I think so. When the pull gun comes. I want you just quick. Busy. right? Should be done. They gave you a PDF and where key between 0 and 5. Sorry, 1 and 5. 1, 5. Right, is key, right? Calculate the value of key and sketch the graph of f of x in the same space. So I'm already fighting up with that, right? That's equal to 4 multiplied by key. Right, if you want, you should write it like this, huh? I just being lazy, right? You should write it like this is equal to 1. So that is, because you know it's a square, a rectangle, is k multiplied by 4 is equal to 1. So I got k to be a quarter, right? Now you can sketch it, right? K is a quarter. Anybody else get that? K is a quarter. Yeah, right? This is f of x, right? Next, they want you to find e of x and variance of x. Right? Find that quick. Tell me what you get. Right, same thing. Write down what's e of x, write down what's e of x squared, and then work out variance of x. Just see your message e of x value from a e of x and variance. E of x is 3. But you got the E of x squared. You found E of x squared, does it? Okay, go ahead now. I think anybody else doing it, but you go ahead. Maybe Chida invites you now.
Dwight, Dwight, good night, Dwight. I was there for your call, Dwight. After press play, Benedict's for the last couple of years, you have been calling me after every game, Dwight. Where is your call tonight, Dwight? I'm waiting on you. Come in, Dwight. Dwight. Dwight.
Right, E of x squared, you got 31 and 3 or 3 and a 2? 31 and 3 or 3 and a 2? Okay. Right, and then you find variance of x, right? Alright, next one. Alright, next part. They want you to find the probability. So you're integrating between 3 and 4.5, but the part this is the part I'm interested in. Right? So again, we know what the function was, right? The function was 1/4 between 1 and 5. We wanted to find the f of x, right? So I'll give you 2 minutes, see if you can do it, and then we sketch it. Right? Remember to find f of t first, and then we will do a little sketch. Remember, you have to consider everything, right? Less than 1 and bigger than 5. I'll give you 2 minutes and then I will start to do it. Right, so you should have it by now. So f of t is the integral between t and 1. It's a little bit different here between t and 1 of k. Sorry, we know what k is now. K is a quarter. Right? When you integrate, you'll get x over 4, and you have to plug in t and 1, right? So it's a little bit different now. You have to plug in t and 1. So you're going to get t over 4 minus a quarter. Or you could write it like this, t minus 1 over 4. Right? That's what your function will look like. So what does f of x look like? Is 0 for all the values less than or equal to 1. Right? Between 1 and 5, it is x minus 1 all over 6. And it's 1 for all the values bigger than 5. Okay? That's where your function will look, sorry, 4. Right? I wrote that bad, sorry. It looked like a 6 on this side. 4. Right? And that's it. That's how you represent your cumulative distribution function. All right? All right, nice. So all we really have to do, we could do a little 1 or 2 questions again and wrap up this module. Main focus now is module 3. Right? I didn't timetable you all because I was thinking of doing the classes the last week of the holidays. I mean, the last week of school. Right? So I'll just message on the group next week to remind you all, right?